Good day, everyone. So, how are you? Okay. So, before we will proceed to our proper discussion, we will first have our prayer. So, who can lead the prayer? Yes, Miss Cruz, please lead the prayer. Amen. So, I will first check your attendance. I know I will just screenshot the attendance. Just wait. Okay. Who has an idea on what is going to be our topic? None? Okay. Our topic for today is all about mathematical induction. So, what is mathematical induction? Anyone? Okay, you have no idea? Okay. So, in algebra or in other discipline of mathematics, there are certain results or statements that are formulated in terms of n, where n is positive integer. So to prove such statements, well-suited principle that is used based on the specific technique is known as the principle of mathematical induction. So in order for us to prove n where n is positive integer, there is a specific technique on what to use to prove that n is a positive integer. So, principle of mathematical induction. So, the principle of mathematical induction is one such tool which can be used to prove a wide variety of mathematical statements. So, this is a tool. Ito yung ginagamit para ma-prove that n is a positive integer. Each such statement is assumed as P of n associated with positive integer n for which the correctness for the case n is equals to 1 is examined. Then assuming the truth of pk for some positive integer k, the truth of p of k plus 1 is established. So if we are going to use this principle of mathematical induction, where p of n is positive integer and n is equals to 1, when it is true, assume that pk is true so that pk plus 1 is also true, or pk plus 1 will be established. So there is a given statement p of n involving the natural number n such that the statement is true for n is equals to 1, and if the statement is true for n is equals to k, so if the statement is true for 1 is equals to k or n is equals to k, the statement is also true for p of n is equals to k plus 1. Then p of n is true for all natural numbers n. So if your n is equals to 1 is true, the following steps of the principle of mathematical induction is also true. So example number 1. So where our problem, wait, before we will proceed to our example, do you understand what is the principle of mathematical induction and what is mathematical induction? Any questions? So to further understand what is mathematical induction, we will have our first example. So problem number 1. Prove 1 plus 2 plus 2 squared plus 2 cubed plus dot 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 plus 2n minus 1 is equals to 2 raised to the power of n minus 1. Okay. So let P of n is equals to 1 plus 2. This is the problem, okay? 2 squared plus 2 cubed plus dot 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 2 raised to the power of n minus 1 is equals to 2 raised to the power of n minus 1. So let n is equals to 1. So we will prove here that 2 raised to the power of n minus 1 is equals to 2 raised to the power of n minus 1. So let's copy. So let's copy the 2 and 2 raised to the power of n minus 1 is equals to 2 raised to the power of n minus 1 and substitute 1 to n and substitute n to 1. So P of 1 is equals to 2 raised to the power of 1 minus 1 is equals to 2 raised to 1 minus 1. So in the first term, we have 2 raised to the power of 0. And in the second, we have 2 raised to the power of 1 is equals to 2. So minus 1. So minus 1. Okay. So 2 raised to the power of 0 is equals to 1. Since all numbers raised to the power of 0, the answer will be 1. So 1 is equals to 2 minus 1. So 1 is equals to 1. So Pn or Pn, n is equals to 1 is true. Okay, any question with regards to P of n is equals to 1. So we will now proceed to our second step, which is the n is equals to k. To prove that n is equals to k plus 1. So we will substitute all n to k. So 1 plus 2 plus 2 squared plus 2 cubed plus 2 n raised to the power of 1, 2 raised to the power of n minus 1. We will substitute the 2k minus 2 raised to n to 2 raised to k minus 1 is equals to 2 raised to k minus 1. So, we are done substituting. We will now proceed to let n is equals to k plus 1. So, we will now substitute again. So, 2k raised to the power 2 raised to the power of k minus 1 plus 2 raised to the power of k minus 1 plus 1 is equals to 2 raised to the power of k minus 1. We come up to 2k minus 1 plus 2 raised to the power of k. 2 raised to the power of 1 plus 2 raised to the power of 2k minus 1 is equals to 2k plus 1 raised to the power of 1, which is yung maiiwan na lang is 2k minus 1. So, in every here in this problem, we prove that 1 plus 2, 2 raised to the power of 2 plus 2 raised to the power of 3 plus dot 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 2k minus 1 is equals to 2 raised to the power of k minus 1 is true. P of k plus 1 is true. So understand. Any question? None. So we will now proceed to our example number 2. So example number 2. Prove by the principle of mathematical induction that for all n 1 over 1 times 2 plus 1 over 2 times 3 plus 1 over 3 times 4 plus dot 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 plus 1 over n times n minus 1 is equals to n over n plus 1. So first, we will prove or we will show that n is equals to 1 is true. Okay. So let n is equals to 1. So we will substitute that 1 over n times n plus 1 is equals to n over n plus 1. So 1 over 1 times 1 plus 1 is equals to 1 over 1 plus 1. So 1 times 1 is equals to, and 1 plus 1 is equals to 2, and 1 times 2 is equals to 2. So 1 over 1 plus 1 is equals to 2. So 1 half is equals to 1 half. So P of n, where n is equals to 1, is true. Okay? You follow? Very good. Any question? None. So let P of n be true for some natural number k. So we will again substitute the given n to k. So 1 over k times k plus 1 is equals to 1 over k plus 1 times k plus 2. So k plus 1 is equals to 1 over k plus 1 times k plus 2. Okay, next is we will now substitute k plus 1. Okay, we will prove that P of k plus 1 is true. So, k plus 1, k times k plus 2 plus 1 over k plus 1 times k plus 2 is equals to k squared plus 2k plus 1 over k plus 1 or k plus 2 times k plus 2. So is equals to k plus 1 squared over k plus 1 over k plus 1 times k plus 2. Since we have the same denominator, we canceled k plus 1 in the numerator and k plus 1 in the denominator. Since there are k plus 1 squared, there will be left k plus 1 over k plus 2 for k. So therefore, P of k plus 1 is true. Okay, gets? Any questions? Clarifications? None. So, okay, I will cater all the questions later when we are done with example number 3. So, this will be our last example. So, example number 3. So prove that, sorry. Okay, example number 3. Prove that 3 plus 6 plus 9 plus 12 plus plus 3n is equals to 3n times n plus 1 is over 2. So we will prove that 3n is equals to 3n times 3 times n plus 1 over 2. Okay, wait. So solution. Let n is equals to 1. P of n is equals to 3 plus 6 plus 9 plus 12 plus 3n is equals to n plus 1, 3n times n plus 1 over 2. So P of 1 is equals to 3n, 3 times 1 is equals to 3n times n plus 1 over 2. So 3 times 1 is equals to 3. So 3 times 1 is equals to 3 times 1 plus 1 over 2. So 3 times 2 over 2 is equals to 3. Since 3 times 2 is equals to 6, divided by 2 is equals to 3. So P of n, therefore, P1 is equals to 3 is P1 is equals to 3 equals 3. So therefore, P of 1 is true. So since P of 1 is true, let Pk is equals to 3 plus 6 plus 9 plus 12 plus 3k is equals to 3k, k plus 1, 3k times k plus 1 over 2. So, we arrived with 3k, 3 times k plus 1 is equals to 3k, k plus 1 times k plus 1 over 2. So, tell me later if saang part nyo hindi naintindihan because I will cater questions later. So, let k is equals to k plus 1. So, we will now prove that P of k plus 1 is true. Okay, excuse me. So, 3k times k plus 1 over 2 plus 3k plus 3 times k plus 1 over 2 times 2 over 2 is equals to 3 times k plus 1 times k plus 1 over 2. So 3k k plus 1 plus 6k plus 1. So where did I get 6? It is from 3 times 2. Okay, is equals to 6. Then copy the k plus 1 over 2. So 3k, k plus 1 plus k plus 2. Okay, since 6 is divisible by 3, it is divided by 3 both sides. The 6 was cancelled out, and 2 times 1 is equals to 2. Then we get 3k times k plus 1 plus k plus 2 over 2. So is equals to 3k k plus 1 plus k plus 1 is over 2 is equals to 3k plus 1 plus 3k times k plus 1 times k plus 1 over 2. Therefore, P of k plus 1 is true. So therefore, we proved that all the given problems is true for P of n, P of k, and P of k plus 1. So I guess that is all our examples for today's discussion. So, anyone, any questions? So, always remember that in mathematical induction principle, that if P of n is true, P of k is true, that is why we establish that P of k plus 1 is also true. Okay. Do you understand? Any questions? So in our next meeting, please do study our lesson. I will just post this on our Google Classroom, and I will give quiz next meeting or activity next meeting. Study well your lesson so that you can answer the following questions or the activities. So, sure na walang questions? Did you understand? Okay. So, for the information of everyone, I will just post this on our Google Classroom. Okay, thank you, class. You may now leave. I wait. I will screenshot again the attendance to see who stayed, and I will give points for those people who stayed. Kasi medyo complicated yung topic, kaya we need really a a virtual meeting. So, okay, we're done. So, thank you, class. And once again, good good day. So, you may now leave the classroom. Thank you and goodbye.